Pre-Calculus Chapter 1, Lesson 1. In this video we want to look at problem solving, some tools that we use to problem solve, and then some tips that we need to use to problem solve as well. So problem solving in mathematics usually involves solving an equation, and it comes down to finding a value where the expression equals 0. This is something that's going to be very, very common that we do throughout the year. We get the equation, we get it set equal to 0, and once it's equal to 0, which is most useful because it allows us to use the zero product property, which says if the product is 0, in other words, if you're multiplying two things together and the answer or the product is 0, then that means that you know that one of the factors is 0, and it doesn't matter how many factors you have, one of them has to be 0. And we've done this quite a bit over the last year, and it's something that we just need to remember. So if I have x times x plus 3 times x minus 7 times x plus 15, and it doesn't matter, I go on and on. Once I know that it all equals 0, then I can solve for x very easily, because I know that one of these four things, if the product is 0, has to be 0. So then x could be any number that would make any of these 0. So I would take a look at this first one. So how would I make x 0 here? Well, that would be 0 by simply substituting in the number 0. What number would I substitute in here to make this one 0? Well, I would substitute in -3. What number would I put in here? 7. What number would I put in here? -15. So if x were any one of these values, then this product here on the left would be equal to 0. So this is very important and very useful. So if we have the equation where everything's on one side, it's equal to 0, it allows us to use the zero product property, which is very valuable when we are trying to determine the value of x. So graphically then, and again, this whole book's about, seeing the relationship between the algebra model and the graphical model. Graphically, setting the equation equal to 0, that means we're looking at the x-intercepts. So if I go back to this example here, this again is the algebraic model. What's the connection between these numbers here that I determine algebraically and the graphical model of the same expression? These numbers actually end up being, because it's equal to 0, this is actually the y value, okay, because I'm trying to find x, we know that y is 0. These numbers are actually the numbers of the x-intercepts. So this graph is going to cross the x-axis at 0. At -3 it's going to cross the x-axis. At 7 it's going to cross the x-axis. And at -15 it's going to cross the x-axis. So these 4 points of the graph are what these numbers represent. So again, that's the tie-in between the algebraic model and the graphical model. And so it's very important to make that connection, understand. When the equation is equal to 0, that means we know the y value is 0. And every y value on the x-axis is 0. So any x value that makes this equation true is a point on the x-axis when we're looking at the graphical model. So again, if the equation is set to 0, then we're looking at the x-intercept. Now, if the left side is equal to the right side, then we're looking at the intersection. So looking at the connection here, let's say this is similar to this in that we had x and x plus 3 on the right, or on the left, excuse me, and we had x minus 7 and x plus 15 on the left. Okay, how is the intercepts? This is not equal to 0 anymore. So if I was to graph this, the graphical picture here, it would no longer be, I would no longer be looking for where it crosses the x-axis, because the equation is not set equal to 0. I don't know what the y value is. Okay, so in this case, where you have an expression on the left equal to the expression on the right, the graphical connection here is, if you were to graph this, and I know it's a quadratic, I don't know exactly what it looks like, it might look something like this, and this over here, it's also a quadratic, and again, I'm not sure what it looks like, I'm just guessing here. It might look at something like this. Okay, What am I looking for here? I'm not looking for where it crosses the x-axis because this is not equal to 0. I'm actually looking for where this graph is equal to this graph, and that's going to be where they intersect. Okay, so again, understanding the connection between the algebraic, what I'm looking at algebraically, and what I'm looking for graphically, that's the major point of what we're trying to understand here. So in this case, where you have an expression on the right and left, you're looking for the intersection. Here, where the equation is equal to 0, you're looking for the x-intercepts. So that's the connection. Now, what's the connection in a table? Well, in a table, if you were to take the expression and it was equal to 0, you're looking for where it crosses the x-axis. So let's take this example here. In the table model, what you would be given is you would be given a list of x values down here. Okay, that's what a table is, and then you'd be given a list of y values, and let's say they're negative, 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 and then they change positive, positive, positive. Now, in this particular example that we're looking at here, this is the algebraic model. What makes it 0 gives me this. The graphical picture that I should get is that's where these cross the x-axis. What's the table picture of this? Well, if you think about this where, and again, I don't know what the graph looks like, but let's just say it looks something like this. I realize here that where it crosses the x-axis, that's the algebraic number here. So this is the graph. What am I looking for in the table? What does this number look like in the table? And actually the interpretation is here. If I think about this, all the y values over here, this is a negative, a negative, a negative, a negative. As this graph is going up here, all these y values right through here are negative. But at this point right here where it's 0, on the other side of that, now all these y values are positive. So all of these y values are positive. So the connection in a table would be, if I'm looking at these negative, negative, negative y values, and here, oh, now they're positive, positive, positive. Well, I know that somewhere between this value right here, this x value here, and this x value here, somewhere between these two, these numbers change from negative and positive. So graphically, the numbers went from being below the x-axis to above the x-axis. So at the table, I could kind of get a general picture that somewhere in here, somewhere between here, these x values here, is where that graph is going to make the change. So even looking at a table, I can get somewhat of an idea of where this equation equals 0 if I look for where the positive or where the y values change from negative to positive or positive to negative. Okay, so that's the connection that we're looking for in problem solving, and again, understanding how we graph these, solve these graphically, how we solve them algebraically, and how we could solve them even looking at a table in a way to solve problems. So any of these numbers that we've been looking at then, any of these values here, these numbers, what are they called? What are some vocabulary that you need to know? When you see the word root, so any of those numbers could be considered a root of the equation or a solution of the equation. So any of these numbers here could be considered, or you might hear them explained as what, or asked for, what are the roots of the equation, or what are the zeros of the equation if the equation is set to 0, or what is the x-intercept of the equation. Any of these things, any of these words that you see, the connection you need to make is, oh, they're looking for those solutions to that particular expression. Now, let me spend just a couple quick minutes talking about problem solving, because this is the goal of the book, is to be able to problem solve. And what I really need you to understand are some 4 or 5 basic things, and that is to understand this. It takes practice and patience. Problem solving is not easy, and some of you, I was going to say, but I didn't want to say that, many students really struggle with problem solving because they lack the patience and they lack the practice, and really it comes down to patience. They want to look at the equation, they want to look at the problem, and they want to be able to just see the answer right now, and if they don't, they really don't want to spend the time thinking about it. But I want you to realize this is an upper level course, it's pre-calculus, and solving problems doesn't always come quickly. You have to be willing and have to understand that it takes practice and it takes patience, and you have to understand that you're not always going to get it right on the first try. And what most What happens most often is students will try it once and then they'll just wait. I don't understand this, can you tell me how to do it? Without really going through the process of trying different things. You must be willing to start over and start over again and start over again and start over again and understand that it may not happen on the first try, second try, third try, fourth try. But you have to be willing to start over. And you can't always have someone just after one try, trying it once, say, "Oh, see, I don't get it," and then have someone tell you how to do it. You have to be willing to start over. It's not always going to be quick, but what you can't do is give up. You can't give up. And seek help. And again, that's one of the reasons why we're flipping the classroom, is so that you can get this help in the classroom. But you do have to understand that you do have to be willing to keep trying over and over and over again. So there's one final thing I want you to do is go to page 76 in your textbook and read the problem-solving process. There's a little chart in there, some steps to remember that you need to keep doing, and tips to helping you problem solve. So read those and take those to heart, and just remember that problem solving isn't always easy. And problem solving rarely, especially in the upper levels, is accomplished on the first try. Unless you've had a lot of practice doing it, and then you can see these problems a little bit easier as you move forward.